started yet?
Oh yeah.
Fantastic. Alright guys, welcome back. Today we're going to be talking about kinetic energy. Now kinetic energy is simply energy in motion. So what we're doing here, kinetic energy in motion is things that are moving around. Things that are constantly moving, that they have kinetic energy. Things like, we have three different ways of saying kinetic energy. We have thermal, electrical, and radiant. Well, there's more than that, but we're going to go ahead and focus on just those three main ones right now. The first one being thermal energy, which is heat energy. Take, for example, water boiling on the stove. As those water molecules heat up, they get excited, they move around more and more and more, they cause vibrations and rub against each other, causing more and more friction, which ends up having that nice little boil that we see whenever it's heated up to the right temperature. Next one is going to be electrical. Now electrical energy, electrical kinetic energy, is simply electrons flowing through a circuit. And then finally we have radiant. Radiant is indirect. So let's take, for example, you go outside on a nice hot summer day and you feel that the heat from the sun kind of bearing down on you. That is going to be the sun radiating that energy on you. And we measure it using one simple formula. And that formula is Ke equals 1/2 mv squared. Now what does all of this mean? Well, let's take a look here on the side and figure out what each one of these are individually. Ke is kinetic energy. Again, like we said, kinetic energy is energy in motion, and that's going to be measured always in joules. Okay? Then we have 1/2 m. Well, half, again, simply just straightforward half in the calculator as 0.5. But m is nothing new. It's going to be mass. So half of our mass is kilograms, and then multiplied by our velocity squared, v squared. Nothing new there. Same terms that we've used before, so it should be really easy. So let's take a look at our equation here. It says number one, Roger Maris swung a bat which has a mass of 2 kilograms at a velocity of 45 meters per second. How many joules of kinetic energy could he give to a ball? Well, we have our information for us. Let's go ahead and pull it out. A mass of 2 kilograms. So mass equals 2, and we have a velocity of 45 meters per second. How many joules of kinetic energy could he give a ball? So we're looking for kinetic energy. Again, the equation is Ke equals to 1/2 mv squared. We're still looking for Ke, so we'll pull out information out there on the side. Equals to 0.5 multiplied by our mass is 2, multiplied by our velocity squared, 45 squared. And we take our handy dandy trusty calculator that we keep with us at all times, which you kind of do. I mean, you have your cell phone, they have calculators on them. And we can go ahead and figure this out. So we have 0.5 multiplied by our mass. Our mass was 2, and multiplied by our velocity squared, 45 squared, and that gives us 2,025 joules. But that's not the only way to do this. If you're a fan, like me, of triangles, we can do it the triangle way. Kinetic energy is equal to 1/2 m, so 0.5 m v squared. We'll plug this information in to what we do know. We don't know what Ke is, but we do know half of 2, 0.5 multiplied by 2, which is 1, multiplied by 45 squared. And if I take 45 and I square it, I get 2025. 1 times 2025 is going to be the same. Ke equals 2025 joules. So 2025 joules. Very easy. Both ways work the same. So work whichever way works best for you. So I'm going to go ahead and move on to the next question. It says a golf pro has 2,100 joules of kinetic energy and swings his driver which has a mass of 0.75 kilograms. What is the speed of his swing? Let's pull out the information that we do know. We know that he has a kinetic energy of 2,100 joules. and he swings that driver, which has a mass of 0.75 kilograms. Mass equals to 0.75 kilograms. And we're trying to figure out his speed or his velocity. Well, we don't know that, but we can go and plug it into our equation and see what it is. Well, we say Ke equals 1/2 mv squared. Well, Ke is 2100 equals to 1/2, which was 0.5. M, we said mass was 0.75. Multiplied by our velocity squared. Now, we don't know what our velocity squared is, but we do know that if we multiply these two together, we're going to get a number. So if we take 0.75 and multiply it by 0.5, we get 0.375. So 2100 equals to 0.375 v squared. Still trying to get v squared by itself, so we'll divide each side by 0.375. And these will cancel each other out, but it'll move it to this side. So we'll have 2100, and we'll divide it by 0.375, and we'll get 5600 equals to v squared. Not looking for v squared though, we're trying to find v. So to do that, we'll square root our answer. And when we end up square rooting the answer, it becomes 74.83, and that's going to be meters per second. There is another way to do it. Just like we said before, we're going to put this in the triangle form. We'll put it in the triangle form where PE goes on top, or PE, KE goes on top, and KE is going to be 2100. And then we have 1/2 our M, so 0.5 multiplied by 0.75. And we don't know what v squared is. So it's going to be 2100 divided by 0.5 times 0.75. So we get 2100 divided by 0.5 times 0.75. We get 5600. And that still equals to v squared. So when we square root this out, we'll get the same number as we did before, hopefully. Square root our answer, and we have 74.83 meters per second. And that's it. If you guys have any questions, talk to your partner next to you. And if you also don't understand, go ahead and raise your hand, talk to one of the teachers, and we'll hopefully get you on track and get you right where you need to be. See you guys next time.